21, 20, 20, 21, 23, 24. Right. So 20th question. So did you all do the 20th question? You can send the answers for the 20th question in the chat. So we'll be going into the 2D resistance systems, 3D resistance systems, and potential dividers and Wheatstone bridge. So today, like those parts are mainly based on questions, right? It won't take much time for the theory, mainly questions. And with that, by finishing Wheatstone bridge, we will have finished the most basic parts, but the most essential parts of the lesson, right? The other parts which certain people doubt say as hard, like Kirchhoff's laws, energy, power in electricity. Then we have the practical moving coil meters. Those three parts are very easy, right? When you know the basic stuff. The hardest part is this basic part for you to understand is this basic part. Hardest in the sense, like it's easy after you understand it. So when you have understood it, the other three sections that we will be going through, the moving coil meters, Kirchhoff's laws, and power and energy, will be very simple for you. There's nothing much to teach them. I mean, you will be able to understand it by yourself even when you know these basic things. And after that, we have the practical. So I will be doing the practicals as well. I will be giving you a full practical note with all the special MCQ points, and I might be able to give you the the categorized structured disease as well. Uh, so the lesson will be fully completed by the end of next month, no? Yeah, July. I've in the schedule I put I think July, so it will be completed in around 2 months. Right. So another about 5 or 6 days to finish current, right? So, right. But that won't be rushed. We will do a lot of questions, and this question duty is only for these 3 days. These 3 days, and I'll send the rest of the questions from next week onwards. Right, I'll send those as well. But so you can think of the magnitude of the questions, number of questions that will be doing, right? And also after the lesson is fully over, I will hold a separate session for you all to do the past paper questions as well, because for the past paper questions, the MCQs, there are lots of questions. So this after today is over, right? After today is over, you can go through the Pesuru book, the first part, right? They have the resistor combinations and stuff. Though that has the most number of questions in current lesson, right? Around 60 to 70 questions, I think. So after this part is done, you can do all that. And I will be going through all that as well, but at the end of the uh, lesson, because it's easier then when everything is done when you do the question, right? Um, yeah. So that will be done in a separate session. I'll let you all know about that when by next month end. So let's go to the question. 1 meter long wire is broken down into two unequal parts P and Q. So there's a wire which is 1 meter long. This is 1 meter long. It is broken down into two unequal parts P and Q. We don't know which one is long, okay? P part of the wire is uniformly extended into another wire R. It is uniformly extended into another wire R. Length of R is twice the length of P. So if P is L, R is 2L. And if P is L, Q should be 1 minus L. Right? And they say the resistance of R is equal to that of Q. Right? Resistance of R is equal to that of Q. So we can write R R, resistance of R equals to resistance of Q. So we know the resistance equation. R equals rho L over A, right? And you know that for a given material, rho is a constant. It's resistivity, right? So resistance depends on the length and the area. So we know we have gotten something of an expression for lengths between these three, but we have to consider the area. If area of P is A, area of Q will also be A. It's the same via, no? But area of P and R are different. Let's say for R it's A dash. Why are they different? Because now the wire is stretched. No? Like if there's a clay, there's like a clay ball or something, when you do it like this, it will be stretched into a thin part. But the volume is constant. Now the wire is thinner, right? Initially it was thicker. So we can write A into L is equal to A dash into 2L, right? So L and L can be cut. A dash equals A over 2, right? So you can get that and find the resistance. So you do know we did last day, right? Volume is a constant for P and R. Volume can't be changed, right? That's what we did now here, equalizing. So when you multiply this equation by L over L, you get R equals rho L squared over AL. AL is the volume. When you stretch something, the volume is constant and rho is constant. So R proportional to L square. Yeah, sorry about that. R proportional to L square. Okay. So here length is twice, right? Length is twice, right? So R over RP. We are going to get. Length of R is 2L. That's squared over L square, which is the length of P. So L square and L square get cut. You get R is equal to, this goes to this side, L and L gets cut, 2 square is 4. Yeah. R, resistance of R equals 4 times the resistance of P, right? So this is equal to 4 times RP. So now you have a relationship between P and Q. So 4RP will be equal to RQ because the resistance of R is equal to the resistance of Q. So 4 times rho L over A is equal to rho 1 minus L over A for Q. Rho and rho get cut, A and A get cut. 4L equals 1 minus L. 5L is equal to 1. L equals 1 over 5, which is equal to 0.2 meters. So ratio of resistances between P and R we have found it's 4. So 1 over 4 to 4, right? Depending on what ratio you take. The ratio of lengths of P and Q. So length of P is L, Q is 1 minus L, right? So for P it's 0.2, for Q then it's 0.8, no? 1 minus 0.2, no? So 1 over 4. Same, no? It's the ratio of resistance of P and R will be equal to the ratio of the lengths also. Because area is the same. Did you all get that correct? You can send in the chat. If you have questions also, you can ask. Okay? Because now is the time for you to ask questions and like understand these things properly. You can make mistakes. You have enough time to make mistakes. But 1 year from now, You won't have time to ask questions to make mistakes, right? So make the most mistakes that you can right now. Right. Let's go to the next one. So next one is 20%. When 115 volts is applied across a wire that is 10 meters long and has a radius of 0.3 millimeters, current density is given. So you are given a wire that is, so it has a radius, so it must be a circular wire, 10 meters and zero point 0.3 millimeters. Always write in meters, always write in standard units. 0.3 millimeters is 0.3 into 10 to the power minus 3 meters, right? 115 volts is applied across this conductor. Then you get a current density J is equal to 1.4 into 10 to the power 4 amperes per square meter. So current density is current divided by the area, right? Current divided by the area. So current is J into A, current density into area. And also they have given voltage. They're asking for resistivity. So you need resistance to calculate resistivity. No? R equals rho L over A. Calculate this, you need the resistance. You can calculate length, you can calculate area, but you need an expression for R. They have given the voltage. So you can apply our basic equation, which is Ohm's law. V equals IR. Then R is V over I. No? R is equal to V over I. Then I is equal to J into A. We substitute that here, J into A. V over JA equals R. Right? Then we can substitute it here. R equals V over JA, which is equal to rho L over A. See how area gets cut. So V, so over J into L goes down, will be equal to the resistivity. So you don't really need this radius, no? You can substitute values at first, Some of you all will do that. You all will substitute areas here and here initially, calculating resistance and current separately. Sorry, here and here, calculating them separately. But that will cost you time, right? If you do this, you only have to substitute once and only three things. If you do like separately, you will have to substitute 1, 2, and also voltage 3 and 4, 5, right? 4 and 5. So you'll have to substitute five things and again equalize the two. No? You have to equalize this with this. So that will cost you time. And time means like costing time is equivalent to costing marks in the exam. Because even 30 seconds, extra 30 seconds can get you at least one full mark. And that can be the difference between an A or a B. So that can be a big difference in your Z square as well. So always do sums in the most simplest way possible. You don't need to always take the long route, right? Sometimes it will be there, but always try to do it in the shortest way. But this is not me saying trying to like අර කනා ගහන්න කියනව නෙමෙයි. හරි shortest way කියලා. The correct but shortest way possible. So voltage is 115 volts. Current density 1.4 into 10 to the power 4 amperes per square meter into length 10 meters equals resistivity. Resistivity you get as, now you all have to either do this manually or use log. So you get 8.214. You had always put into 3 decimal places into 10 to the power. This becomes 11.5. So 11.5 over 1.4 is 8.214. 10 to the power 4 comes up, it becomes 10 to the power minus 4. Okay. Then that will be ohm meter. Yes, ohm meter. Resistivity equals 22 we did. We need to do 23. Always draw a diagram. If there is a possibility that a diagram can be drawn, always draw a diagram. Right? Because diagrams reduce the effort that you need to put to do the sum to substitute from your mind. Otherwise, you will imagine, like you have to imagine this, the sum, no? Right? The When you draw a diagram, it reduces that effort that you need to put from your mind. So you get more effort left in the mind to solve the sum. Right? So always remember diagrams, even simple small ones, they don't cost you time. They make up more time. Right? They save you time. So we'll go to the 23rd one. The resistance of a heating coil at 20 degrees Celsius is 80 ohms. Find the temperature at which the resistance becomes 100 ohms. They have given the temperature coefficient of resistance as 0.05 degrees Celsius. So it's easy when you use this R theta versus theta graph. Like for any conductor, it's a straight line like this now, I equals mx plus c. So at 20 degrees Celsius, it's 80 ohms. Find the temperature at which the resistance becomes 100 ohms. So let's say it's theta at 100 ohms. So they have given the alpha value. Alpha equals 5 into 10 to the power minus 3 per degree Celsius. So our equation is R naught equals R theta 1 plus alpha theta. You will learn something similar to this in heat. I know you haven't started heat yet. You will learn something similar to heat, but it's not the same. Okay. That equation is different. I mean, I'm just saying it so that you will remember those two very easily. Okay, so they have given at 20 degrees Celsius is 80. So we know that this is the resistance at 0 degrees Celsius. It's not the resistance, uh, right? It's not the initial resistance. Okay, it's the resistance at 0 degrees Celsius. So 80 ohms is equal to R naught here, 1 plus alpha is 5 into 10 to the power minus 3 per degree Celsius into theta. Theta we know it is 20. So we get R naught as here 20 into 5 is 100. 100 into 10 to the power minus 3. That's 0.1. 0.1 plus 1. No? Here 0.1. 1 plus 0.1. It's 1.1. 80 divided by 1.1 is R naught. R naught equals to 80 divided by 1.1 ohms. So as a value that would be, we can divide 800 by 11. So this is 7, 77, 30, 2, 22, again 80. So it's a recurring number, no? So 2 times, then for 80 it's again 7, 77, 30, 32, 7. So you can 72.73 ohms is R naught. Then you need to find the resistance temperature at which it becomes 100 degrees, 100 ohms. So R theta is now 100. We're going to find theta equals, this is 72.73 ohms into 1 plus alpha theta. We're going to find theta now. So 100 divided by 72.73. So it would be easier if I just substituted this now. So 100 is equal to 80 over 1.1 into 1 plus 5 into 10 to the power minus 3 per degree Celsius theta. So see, it's 110 over 80. Oh, you can just cut this 0 here itself. So again 10 you can cut 2, here also 2. So it's 5 into 1.1, 5.5 over 4 is equal to 1 plus 5 into 10 to the power minus 3 into theta. Now we don't need to write the units, we already substituted them once now. So 5.5 divided by 4. These kind of ones you don't need the log to just do it just in long division method. So 4 into 1, 4, 15, it's 3, 4 into 3, 12, 3, 30, that's 4 into 7, that's 28, for 20 is 5. 1.375 is equal to 1 plus 5 10 to the power minus 3 theta. So you get 1.375 minus 1 is equal to 0.375 plus 5 into 10 to the power minus 3 theta. So now it's actually theta is equal to 0.375 divided by 5 into 10 to the power minus 3. So minus 3 comes up, it becomes 1000 actually over 5. So it's 375 over 5. Right? I hope you all understood that. So theta is equal to 375 divided by 5 is here for 37 there's 7. Then 2 remaining for 25 there's 5. So 75. Right? Theta equals 75 degrees Celsius. This is 75 degrees Celsius. And they're asking us to find the resistance of the same coil at 250 degrees Celsius. So it's a straight up substitution. No? So I'll just erase this part. Straight up substitution. Resistance at 250. R250 equals R naught. 80 oh, you can just take 72 point something, 72.73 ohms into 1 plus alpha is 5 into 10 to the power minus 3 per degree Celsius into theta is 250 degrees Celsius. So 5 into 250. Oh, it's easier when you take 250 into 10 to the power minus 3. That is 0.25. So 5 into 0.25. 0.25 is 1/4. 1/4 of 5 is 1.25. Right? So here it will be 1.25. Okay? 1.25 plus 1, 2.25. This into 2.25. So 72.73 into 2.25. That is equal to 163.642. If you can write 163.643. So that is the resistance at 250 degrees Celsius. You can mark that also in the graph. So at 150 it is. I mean, I know it's not perfectly linear because like from here to here is just 50 and here to here that's 175. Just to get an idea of how the resistance is increasing. Here is 163.64. At 2. Okay, we will go to the 24th. A heating element using nichrome. Heating element like constructed using nichrome is connected to a 230 volt supply. Connected to a 130 volt supply draws an initial current of 3.2 amperes. So it's a resistance now. Draws a current of 3.2 amperes. Supply is 230 volts. So our home electricity supply is also 230 volts, right? ගෙදරට current එන්නේ 230 volt supply එකකින්. කියන්නේ දැන් අපි laptop එකක් හරි ඔයගොල්ලෝ laptop port ගහන්නේ. And not just any appliance socket එකට ගැහුවාම you get a 230 volt power supply. Right? So මේ එහෙම එකක් ගැන තමයි කියන්නේ. There was an initial current of 3.2 amperes which settles after a few seconds to a steady value of 2.8 amperes. ටික වෙලාවකින් ඔක same supply. Supply එක වෙනස් කරේ නෑ. But current has changed now to 2.8 amperes. Current has reduced actually. This has reduced to 2.8 amperes. So you all know that whatever appliance when connected to a power supply, it will heat up. නේද? Phones රත් වෙනවා charge කරද්දී, laptop රත් වෙනවා charge කරද්දී, blender රත් වෙනවා මේ blend කරද්දී ඒක පාවිච්චි වෙද්දී තව මොනවද තියෙන රත් වෙන දේවල්. ඕනම එකක් රත් වෙනවානේ. ෆෑන් එකක් එහෙම ලයිට් එකක් ඒ වුණත් ලයිට් එක කොහොමද රත් වෙන්නේ? ෆෑන් එකක් එහෙම වුණත් පාවිච්චි කරලා තියෙන වෙලාවක ටිකක් අර මෝටරේ හරිය වගේ අල්ලලා බලන්න. නිකන් ස්ටෑන්ඩ් ෆෑන් එකක් වගේ තියෙනවා. මේ රත් වෙනවා. So whatever appliance that you are using, like which operates on a current, when you are using it for a certain time period, it will get heated. So that means its electrical components will also get heated, right? So you know that whatever the current flows through, the conducting parts the current flows through, when they get heated, their resistance increases. Resistance increases. So from R1 to R2, resistance has increased. So we can apply V equals IR, no? V equals IR. So when the power supply is constant, So when resistance increases, since power supply is constant, now we are trying to supply the same power, or the same voltage, not the power, sorry, same voltage, right? We are trying to supply the same voltage, but the resistance to that current is now increasing. So you can't send that current now. The current will be less, right? Current will be less, or the flow will be less because the resistance, obstruction to the flow is high. So if the obstruction to the flow is high, the flow has to be less, no? So you can apply to them separately to find the resistance R1 and R2 because we have V, we have R also, sorry, we have I also, they have given, right? So what are they asking? What is the steady state temperature of the heating element if room temperature is 27 degrees Celsius? So why have they given room temperature? That is because initially at 3.2 amperes, the temperature is 27 degrees Celsius, right? Because it's not drawing a current, no, it's Dhamma Gavama temperature is equal to room temperature. After a certain time only it gets heated up. That's why they're asking the steady state temperature. Or a steady current එකක් කිව්වේ. අන්න එතනදී තමා මේ steady temperature එන්නේ. Right? And they have given the temperature coefficient of nichrome as well. So we just have to apply equations for R1 and R2 නේද? So that is why diagrams are important. Diagram දෙකක් නේ මෙතන. So 230 volts 230 volts equals 3.2 amperes into R1. So R1 equals 230 volts over 3.2 amperes. V and A, the unknown. Then for R2, similarly, you can write 230 volts over 2.8 amperes equals R. මම කෙලින්ම ලිව්වා ඉතින්. දැන් දන්නවනේ මේක. අපි පෙන්නලා ඉවරයි. හරි. Then you can write R theta equals R naught 1 plus alpha theta. Okay. අර graph එකත් අපි ගහගමු. ලේසි ගහගත්තා. Theta versus R theta. R naught අපි දන්නේ නැහැ. දීලා නැහැ. We have the resistances at two different temperatures. 27 degrees Celsius වලදී R1. R2 is at, that's the temperature they're asking, heat. So you can write for R1, 230 volts, we go net, 230 over 3.2 ohms is equal to R naught 1 plus alpha 1.7 into 10 to the power minus 4 per degree Celsius into 27 degrees Celsius. And you can again write for R2 as well, 230 ohms over 2.8 is equal to R naught 1 plus 1.7 into 10 to the power minus 4 per degree Celsius into theta. Then ඔයගලන්ට පේනවා මේකේ ratios ගත්තම හරි කියලා. ආය R naught හොයන්න යන්න ඕනේ නැහැ මේ equation එකේ substitute කරලා. Easier to get the resistance, no? Easier to get the ratios. So 230 and 230 will get cut and your 2.8 will come up, no? 2.8 over 3.2. Okay, 2.8 over 3.2 because හරිනේ මේ තියෙන්නේ R1 R2 ratio. Right? R1 is less no? Because temperature has increased, R2 is greater. So you can like think about it. තේරුම් නැති වෙන්නේ මං හිතනවා තේරෙන්නේ නැති කියලා මේ තුන් this is at the like lowest part no so that has to come up මෙයා කොහොමද තින්නේ යටින් so that goes down right? Equals to R naught and R naught get cut when you get so 27 into 1.7 into 10 to the power minus 4 ඒක තමයි හදාගන්නේ 27 into 1.7 7 into 7 49 7 into 2 14 plus 4 18 1 into 27 9 15 and 4. How much is that? One decimal place. 45.9 into 10 to the power minus 4. So you get 1, 2, 3, 4. 0.2 zeros. 0.0046 කියලා ගන්න. 0.0046. ඕනේ. Plus 1. That is 1.0046 over 1 plus 1.7 into 10 to the power minus 4 theta. එකට මුකුත් කරන්න බෑනේ. So here you can cut by 4. 4 times 7, 4 times 8. Then you get 1 plus 1.7 into 10 to the power minus 4 equals, cross multiply 8 and 7, 8 over 7 into 1.0046. So here you should get 1.0046 times 8 divided by 7. You should get 1.148 is equal to 1 plus 1.7 into 10 to the power minus 4 theta. Theta. So I'll take it here. Subtract 1 from 1.148. You get 1.7 into 10 to the power minus 4 theta equals 0.148. Now we have to divide it. Okay? Theta is equal to 10 to the power minus 4 becomes plus 4. So 0.148 into 10 to the power 4. So that is 1, 2, 3, 4. බිඳුවක් යනවා 1480. 1480 divided by 1.7. Sorry, 1.80. Let's see, 1.7 with the ones. With unrealistic nature variable. Let's take this one. 8 into 1.0046 into 8. That is 8, 48. 8 into 4, 32, 36. 8.0368 divided by 7. 1.710, 1, 33, 4, 8. Yes, so that is okay. Minus 1 becomes 0.148. Theta 870 degrees Celsius. Is everyone getting that? Did everyone get that? So it's heated to very heated. Oh, so we are also have gotten that. So that must be that everything is correct, but I'm just surprised at the large answer. Okay. Then we can go to the resistor homework that I gave. We will do that and go to the next resistor parts. So again, 5, 6, 8, 9. So first, let's see 5, 6, 8. Okay, fifth one. Three resistors. Huh? So now I will be going a bit fast with these kind of questions, right? You can see three resistances are in parallel, right? 6, 2, and 3. So you have to apply the basic parallel combination. 1 over 1 plus 1 over plus 1 over 3 equals 1 over EQ. So 1 over 6 plus 1 over 2 plus 1 over 3. Common denominator is 6. This one is already 6. The others, you have to multiply this by 3, this by 2 equals 1 over EQ. So you get 1 plus 3 plus 2 over 6 equals 1 over 8. So this is essentially 6, no? 6 over 6 is 1. So our EQ is equal to 1. Equivalent resistance is 1 ohm. Okay, then sixth one. Sixth one is a good sum. Okay. But we did something similar, just a bit extended from that. Okay. So as I told you, you have to mark potentials. No? So here they have given as M. So let's take this as N. Oh, no, it's also M. Sorry. So this is M. You can go along the same line, same conducting wire. You know that the potential is the same unless you meet a resistance where current flows. So this is also M. Take this as N. So this wire is the same wire. You can see here also N, here also N. So I've taken this point's potential as N because they haven't given any symbol. No? So you can take any symbol you want for a given point. Right? But like you have to take it purposefully. I make it a නම් දාගෙන ගියට වැඩක් නැහැ. හරි. Now we'll see what's between A and B. So A starts off with 10 ohms, then goes to point M where 30 ohms is there. And you can see 40 ohms is also connected to M and 120 is also connected from one side to M. Right? So 40 ohms and 120 ohms are also here. 40 ohms and 120 ohms. One side. Then let's start from B. Now we can't see the other side. It's difficult. So let's start from B. There's 35 ohms. B to N. B to N. 35 is there. Then from N to M, you can see 120 is there. Then again, here also N. N to M. N to M. Or M to N, whatever. So it's between, these three are between N and M. So they are between the potentials N and M. So they have the same potential difference. No? So the difference between N and M is their potential difference. They have that same value. So that means they are parallel. Right? These three are parallel. So you can apply this again for these three. For these three only, because the other two are separate. Get the parallel resistance for these three. That would be 1 over 40 plus 1 over 30 plus 1 over 20 equals 1 over EQ. Common denominator is 120. This into 4, this into 4, this into 3, this into 3. 3 plus 4 plus 1, no? 3, 4, and 1. That is 8. 8 over 120 is equal to 1 over REQ. So divide 120 by 8. 120 divided by here 1, 8, 4, 0, 15. 15 ohms. So you can rewrite this combination. Instead of the 3, you can write the equivalent one. That is what is equivalence means, no? Instead of that combination, the resistance that you can put there. That is what equivalent resistance means essentially. So redraw it. 10 ohm and 35 ohms, we didn't solve yet. So you can see these three, the equivalent resistance of these three parallel resistors are in series with this and this. So between A and B, you can just add these three together, 10 plus 15 plus 35. So that is 60. No? So equivalent resistance between A and B, RAB, is equal to 60 ohms. Equal. Yeah, 8 and 9. Let's just go a bit. Right. So this isn't that hard, right? I just wanted you to show that uh, in the questions, you won't always get like nicely drawn words like this, right? You won't get nicely drawn stuff like this. This is essentially what's drawn here. So how they try to mix stuff up in questions is that they arrange the wires in different ways, like in ways that your mind is not used to, your eyes are not used to. right? අර වෙනස් විදිහකට තමයි අර වයර් එක අඹරලා දෙන්නේ. ඒතර අපිට හිතෙනවා මේක අලුත් දෙයක් කියලා. හරි? So the best way to avoid that, avoid the feeling that it is a new thing or it's a different thing that you haven't done before is to do as many resistor combinations, as many resistor patterns as possible. අර ඇහැ හුරු කරගන්නවා කියන්නේ. පුළුවන් තරම් resistor combinations කරාම you know what is what. නේ? අර ඒක නිකන් ඇස්පැන්දුමක් වගේ. It's a bit of magic there, right? ඇස්පැන්දුමක් තමයි තියෙන්නේ. So you can see this 1 ohm and 2 ohm are essentially in parallel, that's in series. 1 ohm and 2 ohm are series. 4 ohm and 2 ohm are series. Made in a series. Made in a series. Made in a series. Series. Why? Because the same current has to go through these, the 1 and 2. මේ බෙන්ඩ් එකක් නේ තියෙන්නේ. Same current will go. Current එක එළියට හැලෙන්න බෑනේ නේ. So same current will go through these two. These two, these two. So you can just add them together, no? 1 and 2 is 3. 4 and 2 is 6. 3 and 4 is 7. Then here also 7, 6 and 1. Then 5 and 6 is 11. And 3 and 8 is again 11. So you can see 3 and 6. Now these are parallel, no? They start at the same point, they end at the same point. So they are parallel. Starting point, ending point, same. I mean it. Right? So they are parallel. 7 and 7 also parallel. Starting point, ending point, same. So මෙතන ලේසියෙන් ගන්න පුළුවන් දෙකක් තියෙනවා. එකක් තමයි 7 and 7. So we did that equal resistances are in parallel. If there are two, you just divide the value of 1 by 2. That is 3.5 again. Now 11 and 11 to 5.5. That if there were three resistances, divide that value by 3. හතේව තුනක් තිබ්බොත් 7 over 3. But here you can do that. This, we got an equation R1 R2 over R1 plus R2. එහෙම නැත්නම් වෙනම දාන්නත් පුළුවන් කැමැත්තක්. 3 into 6 plus 3 plus 6. 3 into 6 is 18. 3 plus 6 is 9. That is 2 ohms. හරි දැන් 3යි 6යි කියන එක ගොඩාක් questions වල හම්බ වෙනවා. ඒතර කරලා කරලාම 3යි 6යි parallel දැක්කහම දෙක කියලා හිතෙයි. ඒක හිතෙනවා. මොකද මට දැක්ක ගමන් හිතෙන ඇත්තට. ඔයගලන්ටත් හිතෙන්න බෑ. දැම්ම නෙමෙයි. right? After you do a lot of sums, you can get it automatically. So 2 plus 3.5 plus 5. 3.5 plus 5.5 is 10. 9. So 9. 9 plus 2 is 11. So again here, this is a definite thing for resistance combinations. You have to draw the diagrams like step by step. හරිද? Steps ගොඩාක් අඳින්න ඕන කියන එක නෙමෙයි මම මේ කියන්නේ. But you when you simplify like big portions, it will become easier as you draw the diagram step by step. මොකද exam එකෙත් සමහරලාට ඒගොල්ලෝ දෙනවා ලොකු ඒවා. හරි ලොකු combinations දෙනවා නිකන් අර තොරණක් වගේ. resistors තොරණක්. එතකොට ඒවත් සමහර ඒවා තියෙනවා මෙහෙම කරත් උත්තරේ ගන්න පුළුවන්. අපි questions වලට ගියාම ඔයගොල්ලන්ට පෙනේ. But there are some which you have to draw. So practice by drawing. අර එකපාර මෙතන ඉඳන් මෙතනට හිතලා ගන්න එපා. මෙතන තව resistor එකක් ඇඳලා මෙතන එකක් ඇඳලා මෙතන එකක් ඇඳලා මේ දෙක parallel නේ. Like you will get the answer, yes. But the chance that you will make a mistake is also high නේ. මොකද බැරි වෙලාව හරි ඒක එක resistance එකක value එක හරි මොකක් හරි පැටලුණොත් your answer will be wrong නේ. Your final answer depends on all the steps here. අර සමහර questions තියෙනවා MCQ එක sorry essay එකක වගේ එහෙම ප්‍රශ්නයක් නැහැ. essay එකක උඩ කොටසට වෙනම ලකුණු හම්බ වෙනවා යට කොටසට වෙනම ලකුණු හම්බ වෙනවා. ඒතර උඩ එක වැරදියට ගත්තත් යට එක සමහරලාට ගොඩක් වෙලාවට ප්‍රශ්නයක් නැහැ. It's not a continuous thing. But here MCQ එකක විශේෂයෙන් resistance combination in MCQ වලට. So final answer will depend on all your steps above. එක තැනක හරි වැරදුනොත් the answer will be wrong. ඒ නිසා හැම වෙලාවෙම අර clear diagrams ඇඳගන්න don't go overboard on diagrams. අර පොඩි එකෙන් පොඩි එකටම දැන් මේ දෙක solve කරලා වෙනම diagram එකක් අදිනවා. මේක solve කරලා තව එකක්. එහෙම නෙවෙයි. Right? Right. Have a certain set of steps. Okay. Let's go to 9. So 9 is also like that. So 6 and 3. අන්න දැන් ආයේ හදන්න යන්න ඕනේ නැහැ. 6 and 3 කියන්නේ 2. So practice the same resistor combinations again. හරි. අලුත් ඒවා හොයම again අලුත් ඒවා හම්බෙද්දි කරන්න. But practice this again and again because තව සති දෙකකින් වගේ මේ ටික කරන්න කිව්වොත් සමහර ඒවා බැරි වෙනවා අනිවාර්යෙන්. Right? So practice the same ones that we do in class again. එතකොට 6 and 3 parallel නේ එක පේනවනේ. and 1 no. and මේ ටික මේ set එක parallel but මේ දෙන්න series. So ඔන්න ඔය පොඩි පොඩි දේවල් ටික අපි හදලා ඇඳගමුනේ. So 6 and 3 I'll write 2 straight away. 1 no. මෙතන 3 වෙනම දාගමු මොකද මේ දෙක add කරන්න. Here 10 and 8 නා 9 18 and 6 9 18 6 so 4 නේ. I think it's 4. Yes. So you get 9, 16 and 8 in parallel. So apply parallel resistance equation. No? 1 over 9 plus 1 over 18 plus 1 over 6 equals 1 over REQ. Common value, common denominator 9 into 3 into 3. 9 over 18 common denominator into 2 into 2. So 2 plus 1 plus 3 over 18 is equal to 1 over REQ. So that's 6 over 18 is equal to 1 over REQ. So 1 over 3. REQ is equal to 3 ohms. So you can write දැන් මේ දෙකත් add කරන්න පුළුවන් නේ series එකේ. ඔන්න මේ තුනම add කරන්න පුළුවන්. මෙයයි. Right? මෙයා මැද්දේ හිටියට එයාගේ value එක අපි 3 ohm කියලා දැම්මම මේ හතර දෙනාම series නේ. So මම මේ දෙන්නා විතරක් add කරන්න 3 ohm 3 ohm. Oh. So 10 ohm. 3 plus 3 6 plus 4 10 ohms is the equivalent resistance. And we have 11, 14, 16. Yes. We have 11. 11 is here. Yes. So I'll go through 11 fast. If you have any questions, ask. හරි දැන් අපි කරපු ටිකම තමයි 11 වලදී. So that's 30 and 21. නේ? Very odd number. Right. අදගෙන යන්න තියෙනවා. 30. Starting from me, there's 30. මේ දෙක add කරන්න පුළුවන්. So that's 30. Here also 30. Down 40 and 20. 60. මම ලියාගත්තේ පරිස්සමෙන් ලියාගන්න. එක තැනක් හරි වැරදුනොත් ඉවරයි. Then here 10 and 15, 25. 25, 50, and here 80 and 20, no? 100. So 25 and 15, 40. Here 80, and here 50 plus 30, 80. So 40, 80 and 80. ඊට පස්සේ 15, 16 and 8, 24, 36, and 72. නේ 40 plus 32. ළමයි දැන් මේක හදාගෙන යද්දි අර කියවන්න බැරි නම් අර තේරෙනවනේ පැටර්න් එකකට යන්නේ කියලා. නේ බෙදෙන විදිහට තමයි මේක දීලා තියෙන්නේ. ඩෙසිමල්ස් එන්නේ නැහැ. So you can see 16 and 8 පේනවා 24, 36. The multiples of 12, 40 plus එතකොට 32 නේ 72. I said it with respect to this මෙන්න මෙතන. පේන්නේ නැහැ 60 and 20 ද මොකක්ද කියලා. So it should be 60 and sorry 80 and 20. 60 වගේ පේනවනේ. 60 වෙන්න බෑ. So here it's 20. එතන 80 වෙන්නේ. Then you have 21 also at B. But 21 with 30 ඕන add කරලාම ලියා ගන්න පුළුවන් 51, which is not a problem. So 30, 36. 1 over 30 plus 1 over 30 plus 1 over 60. So into 2, into 2, into 2, into 2. That's 2 plus 2 plus 1, 5 over 60 equals 1 over. Here 1, here 12. Right. So R equals 12. So 30 and 21, I'll just add them together. On a second. Here 12. Then what do you get? 25, 50, 100. 1 over 25 plus 1 over 50 plus 1 over half equals 1 over. So here into 2, into 2, into 4, into 4. Here you might get a decimal there. Yes. Come on. You know? So it's 100 over 4, 5, 6, 7. Yeah, you get a decimal. R equals 100 over 7. So 1, 7, 30. It's 14 point. 428 to then you get 0 to 14, 60. You have 8, 14.2. So here 14.2. Then 40, 80, and 8. 1 over 40 plus 1 over 80 plus 1 over 80. Common denominator 80. So 2 plus 1 is 4 over 80 equals 1 over 120. R equals 20. Then you have 24, 36, and 72. Whether about that is just give me a minute, right? I'll be back. Right. Sorry about that. Okay. So where were we? 1 over 24, 36, and 72. No? So 1 over 24 plus 1 over 36 plus 1 over 72 equals 1 over. So common one is 72. 36 into 2 and 24 into 3. 3 plus 2 plus 1 is 3 plus 2 plus 1, 6 over 72. So 1 over. Here 1, there will be 12. Equivalent resistance 12. So here it's 12. So we just add them together, no? So 12 and 12, 24, 24 plus 20, 44, 44 and 51, 95, 95 and 14.28, 109.28 ohms. Now these are not hard sums, I know, but uh, it kind of helps you to develop the art of simplification in resistors. Right? ඉක්මනට කරන්න පුරුදු වෙනවා. So more you practice, the faster you will be able to do the sums. Right. After then it's 14. Simple sum. Right? So R in parallel, and now එහෙම වෙනම connect කරලා තිබ්බට, right? It's the same wire, no? There's no other resistance in between. So if you take the potential here as X, here also it will be X. With wire එක දිගටම X. Right? So you can redraw it as R, then R and R. They are coming to the same potential, X well then. So you can draw it like this also. And may they come to B, right? They come to B finally. But they are also at the other point at X. So 3 R's 3 are in parallel and 2 are in parallel. So R over 2 and R over 3. So what you get is R plus R over 2 plus R over 3. So it's 1 point here, 1.5. Well, you can either take common denominators, but easier than that to get like 1 plus zero point 0.5 plus 0.33. So that's 1.833. Where to put 2 3s? R. Might like මේකත් දීලා fraction එකක් විදිහට අහන්න පුළුවන්. So common denominator 6 so here into 3 into 3 into 2 into 2. 6 plus 3 plus 2 is 11. 11 over 6. Okay, 16. So 16 also is just simplifying. No? So from A there is 20 ohms. And 20 and 25, whatever that must come as equivalent of this will get added to 25 and 25, no? So there is 45, right? 20 plus 25, 45. So you have to get the equivalence of this weird combination now in the middle. So 5 and 5 is 10, right? 5 and 5 is 10. So this, if you try to write, you can draw it, right? But that will take a lot of time, no? 5 and 5 is 10. Then here 10 with 10. Again, so for these three, it will be 5 and 5, 10, 10 with 10, 5. For these three, the equivalent will be 5, right? So instead of all these three, I can just draw one resistor, 5 ohms, like this. You can see again 5 and 5, that is 10. 10 with 10, 5. So instead of all these three, I can draw 5. And again 5 and 5 series, no? That is 10. 10 and 10, 5. So instead of these three, here 5. Then now these are not here, okay? Because we have already done them. No? මේක ඉන්නවා කියලා මෙහෙම හිතුවත් කරන්න බෑ සම. Because then you can't add these other two files won't be in series. So මේ wire එක තියෙද්දි මෙතන. Now 5 and 5 series. That's 10. 10 in 10. That's parallel 10 and 10 is 5. So 45 plus 5 ohms. 50 ohms is the equivalence. I don't advise you to draw that because එකින් එකට අඳිනවා කියන එක එපා වෙනවනේ නේ. Okay, we have only other three questions. Okay. Right. 30, 31, 32. No, 30 is easy, and so is 31. It's again uh, it's a deception of the eyes. මේ ඔක්කොම deceptions. ස්පෙන්නුම් කියන එකට හරි වචනේ deceptions නේද? Magic කියන්නේ මායාවනේ. So deceptions. Right? So here you can see it's A no. මෙතන potential එක අපි කරමු A කියලා. This is B. So here A, you can see same wire. So here also A. මෙතන B, same wire. Here also B. So from A, you get one of these three options. එකක් තියෙනවා. Then here, this also is between A and B නේද? එයත් තියෙන්නේ A and B අතරේ. මෙයත් A and B අතරේ. මෙයා එයත් A and B අතරේ. So all three are between A and B. So it's just a parallel combination. 3, 3, 3, 3 over 3, 1. මෙතන දැක්ක ගමන් කියන්න පුළුවන් දැන්. What is the equivalent resistance of the combination shown in 31? Send the answers you got in the chat. I want to see if you all have understood. Otherwise, yes, I mean, what I teach would be useless. No? Exactly. You have gotten the correct answer. So one no. Make a වගේම තමයි. Why? Because these three start at the same point. And you can see මෙතන B වුණාට අනිත් තැන් ඔක්කොමත් B. The same point is continuing. නේ? You don't encounter any resistances. So all these 3 points are also B. So it's between A and B නේ. බොරුවට මෙහෙම මේ ලයින් එකක් මැද්දෙන් ගහලා තියෙන්නේ. ඒක නිකන් වෙන්න මෙතනින් ලයින් එකක් ගැහුවා වගේ. වයර් එකක් ගැහුවා වගේ. එතනින් එහෙම ගැහුවා කියලා කරන්ට් එකක් යන්නේ. Why? For a current to flow, there should be a potential difference. But these 3 points are at same potential. So if you connect a conductor between the same potential difference, no difference, let me sorry, between the same potential points with the same potential, the current won't flow. Why? අර කන්දක් මං කිව්වේ ගඟක් ගලන්නේ උඩ ඉඳන් යටට. ඒතර උඩක් ඉඳන් යටකටනේ. From high plane to low plane. Horizontally තිබ්බොත් ඒක ගලන්නේ. හැබැයි අර ගඟ ගලාගෙන ඉන්නේ horizontally උඩින් ඉඳන් තල්ලුවක් එන්න නිසානේ. Right? So මෙහෙම මොකක් හරි දෙයක් ගලන්නේ උඩින් ඉඳන් අතෑරියොත් ඔයා ඒක තනිතලාවක horizontal plane එකක මෙහෙම තිබ්බොත් ඒක ගලන්නේ automatically. ඒ වගේ තමයි මේ same potentials කියන්නේ. දෙය ඒගොල්ලන්ගේ high potential to low potential තමයි හැම වෙලාවෙම current එකක් flow වෙන්නේ. Right? So there should be a potential difference for a current to flow, and it flows from a high potential to a low potential. So same potential means they're at the same level. Right? And 32. 32 place. Now you can see these two are parallel. Why? A තියෙන්නේ මෙතන, B තියෙන්නේ මෙතන. So you can, if you want, you can like මෙහෙම තියෙන එක මෙහෙම ඇඳ ගන්න පුළුවන්, but මෙහෙමම කරන්න පුළුවන් නේ. 2 and 2 to parallel. Why? Current is coming from here and going. So 2 and 2 is parallel, and 3 and 3 are parallel. ඒ දෙක මුලින් ඇදගෙන ඉන්නවා. One no. 2 and 2 parallel කියන්නේ 1 no. There's another 1 ohm here also. 3 and 3 parallel කියන්නේ 1.5 ohms. Right? It's 1.5 ohms. 3 එක තිබ්බත් කමන්නේ නැහැ. 3 දෙක තියන්න. 3, 3. So here you can see it's 1, 1, 1. එක දිගටනේ in series. So it's 3 and 3 තියෙනවා මෙහෙම. 3, 3, and 1, 1, 1 කියන්නේ 3. You can put 3 here. So essentially this point A now, sorry, that's B. If this point is B and this is A, you can see all three are between A and B. 3, 3, 3 between A and B. So 3 over 3, 1 no. මේ තුනටම answer එක 1 no. මේ questions තුනේම තියෙන එකම දේ. හැබැයි තුන් විදියකින්. ඔන්න ඕම තමයි resistor combinations එන්නේ. Okay, we can go to resistance systems. So there is nothing different, but just the combination will get bigger now when we go to 2D systems. Yes, it's one. Okay, right. Okay. Uh, Page number 7 on your tube. Page number 7. We did parallel combination. We are going to solving symmetric resistance systems. Right. දැන් ඉගෙන ගත්ත දෙයින් අලුත් දෙයක් නෙමෙයි. It's the same thing, but we are further extending the size of the resistance system, right? The size and more like the pattern, right? So the example we will be taking is this, right? Copy down the values correctly. This inside for R කියලා ගමු. R. Yeah, for Wheatstone. So when solve දැන් මේකේ යාට බැලුවට කියන්න බෑනේ එකපාරට කවුද parallel කවුද series කියලානේ. එතකොට මොකද කරන්නේ? We have to get the we have to see whether it's symmetric, right? So we have to see whether it's symmetric along the axis, right? Along an axis where the resistance needs to be found. The axis has to be between 2 points that the resistance has to be found. The A and B නම් දුන්නේ. The axis should be symmetrical about the axis AB. හරි දැන් ඔයාලට අපිට හොයන්න කිව්වේ මෙන්න මේ axis එක කියලා හිතන්නකෝ මෙතනයි මෙතන. එතකොට බලන්න ඕන CD කියලා ගන්න. You have to check whether the system is symmetrical about that axis. එතකොට AB axis එක වැඩක් නැහැ. හරි so you have to get the symmetry check whether the pattern is symmetric about the axis between the 2 points that the resistance has to be found. හරි දැන් ඇක්සිස් එක මේ ඇක්සිස් එක නැතුව වෙන ඇක්සිස් එකක් අරගෙන හරියන්නේ. දැන් මෙහෙම කැපුවත් ඔයාලට එනවනේ පොඩ්ඩක් සිමෙට්‍රික් වගේ කියලා. එහෙම අරන් බෑ. It has to be along the line connecting the 2 points. perpendicular එක ගත්තොත් බෑ. හරි. මොකද කොහොමද දන්නවද ඒක කියන්නේ? බලමු ඇයි එහෙම කිව්වේ කියලා. right? Right. So one thing is the system it has to look symmetric and the resistance values also need to be symmetrical. Now you can see for this 2R there is 2R here. For this 2R there is 2R here. For this 2R there is 2R here. And for these two there are 2R here. And these are in the axis, so they are cut in the bend. So it is symmetric about the resistances on either sides as well. Now let's just say this was 3R instead of 2R. This one. Now it is not symmetric. Because the value is symmetric නෑ. මෙයාට මෙයා ඉන්නවා, මෙයාට මෙයා ඉන්නවා, මේ දෙන්නට ඉන්නවා. හැබැයි මෙයාට මෙයා නෑ. So it is not symmetric. Because of that one resistance, the whole combination will not be symmetric. Now the current flow is disturbed. Right? So it has to be symmetric for each and every point. And එකට එකක් point symmetric වෙන්න ඕන. Right? If it is symmetric about that axis which is joining the two lines and the resistance values are also symmetric on either sides of that axis, we can consider it to be a symmetric resistance system. Then we can fold that. We can just fold that. Right? And then we draw it again. We have to draw it again. How? When you fold it, this point will get connected with this point. I'll take another color. This will get connected with this. This will get connected with this. Right? These points will fall on one another. So falling on one another means they have the same potential. That is why you can connect them together. Because the question again, when they have the same potential, there will be no current flow across that. Right? That's why we can connect them. So symmetricity is වලින් බලන්නෙත් ඒකම තමයි. If it is symmetrical on both sides, the potential, let's say x at here, will also be x on the same symmetrical point on the other side. මෙතන y නම් මෙතනත් y. මේ වගේ. So you can just fold it. So x and y will superimpose on each other. Waves වල මම හිතන්නේ දැන් කරලා තියෙන superimposition ඒ වගේ තමයි. So we start from A. Now this 2R and this 2R are together. එකතු වෙලා. මෙයයි මෙයයි. එහෙම 2R දෙකක් එනවා. So R is මේ මැද දෙන්න එහෙමම ඉන්නවා. ඒගොල්ලන්ට partners ලා නේ. There are no other partners for them. This 2R gets with this 2R. Awakening. 2R and 2R. And the other 2R will get together with this 2R. Wait, not together. I mean 3R. This 2R. B. And these four. මෙයාත් එක්ක එකතු වෙනවා. මෙයාත් එක්ක එකතු වෙනවා. So there will be here R and R and another R. Then මොකක්ද වෙන්නේ? Now you can solve නේද? You can solve it. So ඔයාලා පල්ලෙහාට වෙන්න අදින්න. මට දැන් මේක පල්ලෙහාට කරන්නේ. මම උඩට මේ පැත්තට දෙනවා. You all can draw it down. Okay? So there are two methods to do this. This is the first method. Okay, so 2 and 2 parallel. 2 and 2 parallel. Here 2 are parallel. Here R and R and R parallel. So ගානට බලලා ගන්න තියෙනවා. So මේ දෙන්නම අදින්න පුළුවන් මොලේ. R and R. Then you have 2R and 2R parallel, that will be R. Another 2R and 2R parallel, that will be R. Another 2R and 2R, that will be R. So R and R parallel, that will be R over 2. This will also be R over 2. Right? That will also be R over 2. Now what do you do? Now what will we do? So you can see this is also symmetric about this point. So if a current of I goes through this side and a current of I dash goes through this side, right? මෙහින් මේ I dash current එක එන්නත් ඕන. මෙහින් I එන්නත් ඕන. They can't mix up. The current can't be different because it's symmetric. Right? So මෙතනින් මෙතෙන්ට I current එකම යනවා. So there is no exchange of currents at this point. මේක connect කරලා තිබ්බට මේ ඔක්කොම එකට middle එකේ there is no exchange in currents that happens. So you can just draw it separate. පොඩ්ඩක් අයින් කරලා අදින්න පුළුවන්. You don't need to connect it. Right? දැන් connect කරත් එකයි නැතත් එකයි. Current එකක් mix වෙන්නේ නැහැ. You can draw separate මෙහෙම. You can see R and R over 2 and R over 2 get connected now. There R over 2 කියන්නේ R. Here R. Then you get R with R. That is also R over 2. එළිම මම R over 2 කියලා දානවා. Why? Here R over 2, that is R and R. Then R over 2. This is R, this is R. Find the equivalent resistance and tell me what it is. So this is how we do it step by step. Practice with the කොහොම තමයි කරන්නේ. දැන් මම මෙතනින් symmetrical කියලා දෙපැත්තට symmetrical කියලා points දෙකට perpendicular axis යන්නේ. මම ඊතර නවන්න කිය නෑ හරිද? එහෙම නවන්න බෑ. මොකද එතකොට A and B you put together නේ. දැන් එහෙම තිබ්බහම A and B එකට වැටෙනවා. You can only like put one point on top of the other if they have the same potential. But A and B will never have the same potential no. ඒකනේ current එකක් A ඉඳන් B ට හරි B ඉඳන් A ට හරි යන්නේ. අපි බලන්නේ ඒකනේ නේ. We are connecting the cell through here. So if this like අපි මුලින්ම කරේ එර්ත් කරන්න පුළුවන් කියලා. This is 0 and the cell's potential අපි හිතමු B කියලා. This will be plus V. So B will be 0, A will be plus V. They will never be the same, equal. Right? They will not be the same potential. So you can't fold it like that, perpendicular to that axis. Right? වෙලාව බලන්න ඕන අපි resistance හොයන්න ඕන මොන points දෙක අතරද. Right? But you can If it is like parallel in another plane, you can use that to like do other stuff. then මෙතන මේක මේ අයින් කරන්න පාවිච්චි කරාවා. But the folding principle only comes when like on either sides of the axis are symmetric. So here R and R is series. That is 2R. But with here R, 2R, 2R and R over 2, 2.5R. 2R with 2.5R. So you can apply REQ equals R1, R2 over R1 plus R2. Right? You can apply that. So 2R into 2.5R over 2R plus 2.5R. That is 4.5. One of the R's can be cut here. 4.5 over, sorry. Yeah, 5. 2.5 into 2 is 5. R over 4.5. So that's 10 over 9. R EQ is equal to 10 over 9. 1.111111. Yes, 1.111 R. I hope the space given is enough. I think. Is there anyone who's still writing, or shall we go into 3D resistance system? If you have a question, you can ask. Right. So we'll go to the 3D resistance systems. So here the example we will use. Now, the 2D resistance system is in the plane. හරි කියන්නේ මේ වගේ plane එකක තමයි තියෙන්නේ. ඒක ඊට වඩා දෙපැත්තට එන්නේ නැහැ. It's only in the XY axis, right? But in 3D resistance systems, it's a three-dimensional object. හරි ඒක නිකන් අර 3D ඉතින්. හරි. It's a three-dimensional object. Like the resistance is arranged in a three-dimensional shape. X, Y, Z axis එකක් තියෙනවා. Axis තුනක තමයි තියෙන්නේ. Right? So here symmetricity එක බලලම තමයි කෙලින්ම ගන්න පුළුවන්. එහෙම නැතුව ගන්න අමාරුයි. මේ කියන්නේ අර symmetricity එක අනුව අපි අර කරේ xy කියලා potentials අරන් දැන් අපි අරගෙන නැවුවේ. ඒ වගේම තමයි මේකෙත් කරන්නේ. Right? But there are different things that you can do when the systems are symmetric. Right? අපි ඒක බලමු. මේකේ කරන්නේ වෙනස් විදිහකට. So they're like same principle but different ways in which you apply it. So now three resistances are coming like this. 3D, හරි? පිටිපස්සෙන් එකක් යනවා තව එකක්. මෙන්න මෙහෙම. You will understand this. So there are three resistances like this. මේ වගේ අත බලන්නකො. මේ තුනක් තියෙනවා. හරි? triangle එකක වගේ. triangle එකේ size තුනක්. sorry tetrahedron එකක් නෙමෙයි. හරි? just අර pyramid එකක් කියන්න බෑ. there's three resistances like this. Okay? and three like this. යටින් තුනයි උඩින් තුනයි. ඒවා අතරේ resistance තුනක් තියෙනවා. හරි මේ ඇඟිලි මේ එකතු වෙන තැන් අතරේ resistance තුනක් තියෙනවා. So it's three dimensional. Okay. So values අපි දාමු 3R 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 2R 3R බලමු 3R 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 අර horizontally තියෙන තුන R and R. So you are asked to find the resistance between X and Y. How do we do this? නිකන් කල්පනා කරලා බලන්න. I'll give you 1 minute and think based on the other principles that we learned in the previous part. So here බලන්න ඕන shape. It must be symmetric about its shape. දැන් අරකේ තියෙන symmetric about an axis නේ. මේකේ axis තුනක් තියෙනවානේ. ඒතකොට එක axis එකක් කියලා ගන්න බෑ. axis එක කියන්නේ මැද්දෙන්නේ xy අතරේ. So you really can't divide it into two sides නේ. Three dimensional නේ. තුනක් තියෙනවානේ. we'll see. දැන් මම ඔක පෙන්නද්දීම ඔයගලන්ට තේරෙන්න ඕන කොහොමද symmetric කියලා. So it's kind of symmetric about plane නේ. දැන් මේකේ plane එක 3 dimensional විදියට අඳින්න අමාරුයි. So it's symmetric about this plane. Right, the plane where the three horizontal resistances are, because මෙතනින් තුනක් එනවා x වලින් y වලින් තුනක් එකතු වෙනවා නේ, and they are of equal values. උඩ තුන යට තුනට සමානයි. දැන් උඩ තුන යට තුනට සමානයි කියන එක නෙමෙයි වැදගත්. තුනට තුන සමානයි. So 3r and here also the all three are 3r. And so I think it's better to take instead of 3r යට අපි ගමු 6r 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 කියලා. නැත්නම් ඔයගොල්ලෝ හිතනවනේ මෙතන 3r ඒවා දෙකක් තිබ්බ නිසා කියලා. Right? Now it's symmetric, right? ඒ paths තුනක් තියෙනවානේ. There are three paths that you can take. Here 6r to 3r 6r to 3r 6r to 3r. ඔය තුන වටේට තමයි කනෙක්ට් කරලා තියෙන්නේ මේ r කියන එක. So just think if these three weren't there, then පොඩ්ඩක් ඒක symmetric නේ points තුනටම equal නේ නේද? Just think if those three weren't there. පොඩ්ඩක් ගලවලා බලන්න. So 3r 3r and 3r 6r 6r 6r. So these 3 points are actually the same point, right? The similar points in 3 equal paths. Similar points in 3 equal paths. So their potential would be the same. You can calculate this if you want also. නිකන් values දාලා බලන්න පුළුවන්. You will get the same answer for the potential at these points. Why? දැන් මේ resistance තුන නැහැ කියලානේ අපි හිතුවේ. එතකොට all the paths have equal resistances නේ 999. That means same currents will flow if you apply a potential difference. Battery එක connect කරොත් මේ paths තුනෙම same current යනවා. So potential drop from here to here will be equal to that from here to here and that from here to here. Same potential drop here again because it's the same current in the 3 paths. So their starting potential is same. X drop එක IR now. This will be X minus IR. So I into 3R obviously. Right? For each and every point the potential will be that. So even if you connect 3 resistances between these points, there won't be a current flow across them. 30 resistances are just for show. අර dummies තියලා තියෙන්නේ. ඒ වගේ තමයි. කරන්ට් එකක් යන්නේ නැහැ. නිකන් අපිව රවට්ටන්න තමයි ඒ තුන තියෙන්නේ. දැන් ඔය තුන නැතුව දෙන්න පුළුවන් නේ. එතන මොකද්ද අපිට කෙලිම ඇඩ් කරලා ගන්න පුළුවන්. But then the question is too easy. There is no critical thinking නේ. So අපිට පටලවන්න තමයි මේ මැද්දේ තුනක් දාලා තියෙන්නේ. අපිට අර potentials equal කියලා ඒ තුන අයින් කරන්න තරම් questions කරලා තියෙනවද කියලායි බලන්නේ. Right? So 3 and 6, 3 and 6, 3 and 6 are parallel to each other. Okay, 9, 9, 9. 9R, 9R, and 9R. So equivalent resistance will be 9R divided by 3, that is 3R. There's another method to do this as well. Then make points ඔක්කොම equal potential. So you can actually pinch these 3 points together. මෙහෙම තුනක් තියෙනවා නම් මේක මෙහෙම එකකින් කරන්න අමාරු. need a thread or something. මෙහෙමනේ තියෙන්නේ. So I'm going to pinch these 3 together. My common point එක pinch කරනවා. Then you can see the 3 R's will start at the same point like this. One, two, three. They end at the same point. 3R, 3R, 3R. Because they have the same potential no B. So you can pinch them together. කිසිම ප්‍රශ්නයක් වෙන්නේ නැහැ. Circuit එකේ කිසි වෙනසක් වෙන්නේ නැහැ. Then 6R is also starting from V and ending from Y. So those three 6Rs are also parallel to each other. So you get 3, 3, 3 parallel is 3R divided by 3 is 1R. 6, 6, 6 divided by 3 is 6, 6, 6. There are 3. The value of the resistance divided by 3. 6 over 3, that is 2R. And R, you get 3R. ඔය විදි දෙකටම කරන්න පුළුවන්. මේ පැත්තෙන් ගියත් හරි මේ පැත්තෙන් ගියත් හරි. But identifying that these three resistances in the horizontal plane are useless is the key. Useless කියන්නේ there is no current flowing through them, right? එහෙම නැත්නම් resistance එක කැඩිලා වගේ මොකුත් නෙමෙයි. These are good resistances. But because they are connected through points with the same potential, they are, you can say that they are useless. Right? They are not needed for the circuit. You can ask if you have any questions. So either you have understood everything or you have understood nothing if you have questions. Only two possibilities are there if there are no questions. එක්ක මුකුත්ම තේරිලා නැහැ. මොනවාද මේ කියන්නේ කියලාවත් තේරෙන්නේ නැතුව නැත්තම් ඔක්කොම තේරෙන්නේ. So we'll see now. So I'll be giving a test at the end of the lesson. At each uh, lesson's end, I will give a test. Like current electricity ඉවර වෙනවා. Yes, so we'll go to a question. I hope you all have copied this. Let's see what resistance system we can do. $39. This one. 39th. Send your answers in the chat. So just draw this again, taking now they make a diagonally again A and B points axis. Draw this again by taking A and B like horizontally. එහෙම ඇඳලා බලන්න සමහරට like uh, all of you have sent similar answers, right? Not the same, but similar answers, but it's uh, not correct. I'll just help you out by drawing it from A, 2 ohm, and so here 2 ohm, and again another 2 ohm, you meet P. ඒ වගේම දෙකක් තියෙනවා මෙන්න. Like this, no? So all are equal. 2, 2, 2, 2. There are many methods you can solve this. Again, එක විදිහක් කියලා බලන්න. has sent the correct answer. You have to draw this step by step. That's how you learn. So I'll do it now. So now you can see is symmetric about the line joining A and B. Right? උඩ දෙකේව 4යි යට දෙකේව 4යි. So fold it. When you fold it, this point will come on top of this point and this point onto this point. So මේ මැද තියෙන line දෙක එහෙමම තියෙනවා. A. So you can just draw the lower half first. Right? Lower half එකට මොකුත් වෙන්නේ නැහැ නේ. ඔබම තියෙනවා. Batman වගේ නේ. Bat වගේ. Batman ගේ symbol එක. Right? It really looks like a bat නේද? Okay. So this 2 will come on top of this one. So මෙයාට තව එකෙක් එනවා. මෙයා මෙතනට එනවා. ඒ වගේම එහා පැත්තට. So 2, 2, 2, 2. So now there are මෙතනින් කරන්නත් කීපයක් තියෙනවා. එකක් තමයි right? එකක් තමයි ඔයාලට පේනවා this point, this is a common wire නේ මැද තියෙන. If you take the potential as x here, මෙතනත් x. Right? මෙතනත් a නේ same wire. මෙතනත් b same wire. So you can see this 2 ohm, this 2 ohm, this 2 ohm, this 2 ohm are between a and x. නේද? ඔය හතරම between a and x. And these guys 2, 2, 2, 2 between x and b. Right? So between a and x means these four are parallel to each other. නැත්නම් ඔයගලන්ට ඕන නම් ඉතින් මේ දෙක වෙනම කරලා මේ දෙක වෙනම කරලා ගන්න පුළුවන්. But it's easy, no? So 2 ohm, 4 2 ohm resistors are in parallel. That means 2 over 4. Plus මෙතනත් ඒ වගේ 2 ohms over 4 between a and b මැද x. 2 over 4 is half. මෙතනත් half. Half and half is 1 ohm. Answer is 1. Right? It's okay to get it wrong. ඔය ටික ආයෙ ගෙදර මේ කියන්නේ අද ක්ලාස් එක ඉවරලා හරි හෙට වගේ නම් හොඳයි. අදම අද කරපු ටික කරන එක තියෙනවා නේ මතකේ හොඳටම තියෙනවානේ. ඒතට ඒක නිකන් කටපාඩම් කරනවා වගේ වැඩක් නෙවෙයි. හෙට වගේ කරන්න ඕනේ. අලුතෙන්. ඊට පස්සේ වැරදුනොත් ආයෙ බලන්න. වැරදෙන එකක් නැහැ. හැබැයි do it not from just memory but මතක් කරන්න principles ටික. මෙහෙම මේ දෙක equal නිසා තමයි අපි මේව කරන්නේ. Those who have finished copying down, do 35. ඔකට මොඩ තියෙනවා. This one. Yeah, one of you have sent the correct answer. This is more, it is a resistance system, but we won't find a symmetricity here. Yes, others වැරදුනාට කමක් නෑ. මොකද වැරදුනා කියලා ඉතින් ඔයාලට හානියක් නෑ. මම බයින්නේ නෑ. So it's better when you send the answer. You can just check it. You get a free checking from me. නේ? නැත්තම් උත්තර කරනකන් ඉන්න එක. You see? Here in between A and B there's foam හතරක් තියෙනවා. ඒකට move කරන්න බෑ. And you can see එහෙම triangle එකක් වගේ එකක් තියෙනවා. දැන් කට්ටිය ඔක නවන්න යන්න එපා. හොඳේ මේ කෑල්ල මේ පැත්තට නවන්න බෑ. එහෙම සමහර අය කරන්නේ නැති like that's okay that happens නේ. Why? දැන් ඒක නැවුවාම that means potential at these 2 points and these 2 points should be equal. But just look at the current flow. මෙහෙන් current එකක් යයි මෙහෙටත් යනවා current එකක් නේ. දැන් මෙහෙට එනවා. එතකොට මෙහෙන් යන එක මෙහෙන් එන්න එපේ. So either current will flow මෙහෙම මේ විදිහට යයි. Then current goes this way. එහෙම. It's a junction no. So whatever current comes in must go. Right? If 10 ohms come, 10 amperes comes, මේ 10 amperes මෙහෙන් ගිහිල්ලා ආයෙත් මෙහෙන් යනවා. So that means at this point, right, there is no mixing. මේ නිකන් bend එකක් තියෙන, bends දෙකක්. නේද? There are only two bends here. Nothing. And not the point where the currents mix. You can redraw the circuit. O, A, B. From A, there's 2 ohms and another 2 ohms. Within a 4 ohms there. And here another 2 ohms and here you can get another 2 ohms. So now you see, no? There's the same current that's flowing through between all these resistors. මෙහෙම යන්නේ current. So all these are in series with each other. 2 plus 2 plus 4 plus 2 plus 2. That is how many twos? 4 twos, that's 8 plus 4, 12. So 4 ohms and 12 ohms parallel with each other. So 4 into 12 over 12 plus 4. 36 over, sorry, 48 over 16. 4 into 12 is 48. 12 plus 4, 16. 3 ohms. Okay, for homework, 236. I can do almost all the sums here. 236. 37 is a cube. So they ask us to find R, AF, AD, and AE. For this week, just do AF. Right? This is the hardest, the hardest resistance system they can give, right? RAF is the easiest out of these three. That means the equivalent resistance between A and F. That's the easiest one out of these three. These two are a bit harder. You can try them. මං කියන්නේ එපා කියලා නෙමෙයි. But I will discuss only RAF next week, right? අනිත් දෙක ඊට පස්සේ week එකේ මම කරන්නේ. Because it's like you like I'm going to give you time to do it. Even when I did, like RAF was quite okay. Our AD and RA took like around 5 to 10 attempts to do it. But if you can do it like with a lesser number of effects, then good. Lesser number of attempts. And also 40th one. So I'll erase this. 36, 37, 40. I'll also write that. 36, 37, 40. Mm, 4. Yeah, no, don't. 41. 43, 46, 47, 40. We do 40. Yeah, okay. 47, 48. How many are there? 7. Do 42 now. Do 42 now. Try to draw it in a different way. Right? මේ දීලා තියෙන්නේ මේ conducting wire එකේ resistance එක, okay? So from here to here it's 10 ohms. So instead of the wire you can draw a resistance here. Right? මෙතන 10 ohms. මෙතන 50. And this wire is 20 ohms. You can draw resistance instead of those things. Okay? And you can do all these things. So for some of them, you need Wheatstone principle as well. That's why I have given them for homework, and I'll give them because we'll be doing Wheatstone bridge as well after doing the potential dividers. So class might go until about 10:50, 10:20, right? Because I will finish it that the basics parts we need to finish today. Point in tracking it towards the next week. So send your answers. One of you all have sent. Yeah. One of you have sent the correct answer. So the key here is drawing the diagram again, right? Drawing the diagram again. Then අපිට පුරුදු A and B දෙපැත්තට තිබිලානේ මේ B එකක් අස්සක ගහලානේ මේකේ තියෙන්නේ. So let's draw it again. And resistance අපි ටික ලස්සනට අඳිමු නේද? From A there is 10 ohms and another 10 ohms, right? And they are connected to this point, connected together නේද? 10 ohm 10 ohm connected together to a common point. එතනින් 5 ohms තියෙනවා. Right? You have 5 ohms from there, which is connected to point B. And from point B, there's 5 ohms is also connected, and maybe 20 එකක් යනවනේ රවුමට. මෙහෙම රවුමට යනවා. Right. It's connected from B to B. මොකක්ද මේ 20 එක කරන්න ඇත්තට? වැඩක් තියනවාද එහෙම connect කරලා resistor from the same point to same point. Current එකක් flow වෙයිද? Because it's connected from same potential to same potential. මේකම තැනට nothing will happen. නේද? Nothing will happen. 20 එක වැඩක් නෑ අයින් කරන්න. So I get two 10 ohms in parallel, that will be 5 ohms plus another 5 ohms. That is 10 ohms. Yeah. So equivalent is 10. මේ 20 එක දීලා තියෙන මොකටද? රවට්ටන්න. right? So we can go to the potential dividers. No? Right. Yes. So potential divide is also something you already know. අපි දන්න දේවල්ම තමයි. So අර දන්න දෙයක් අරගෙන ඒකට වෙනම නමක් දීලා විතරයි මේ තියෙන්නේ. හරි? අර අපි හැමෝම දන්න දෙයක් අරන් ඒකට අලුත් නමක් දීලා තියෙනවා. එහෙම නැතුව මේ නොදන්න දෙයක් නෙමෙයි. හරි? අර නිකන් political parties අර කට්ටිය එක political party එකක් අතහැරලා ගිහිල්ලා එකතු වෙලා තව එකක් හදනවා. ඒතර එකම සෙට් එකේ ඉන්නේ අරකෙත් නේ. බොරු නමක් දීලා තියෙන්නේ. එකම කට්ටිය ඉන්නේ. එකම හොරු ටික ඉන්නේ. එතකොට නම වෙනස් කරා කියලා concept එක වෙනස් වෙන්නේ නැහැ නේද? මිනිස්සු වෙනස් වෙන්නේ නැහැ නම වෙනස් කරා කියලා if it's the same people. So this is also like this potential divide එකත් ඒ වගේ. So we'll see what the potential divider concept is. So we're going to take two resistances. V R1. V is the battery, voltage of the battery. R1 and R2 are the resistances. So we will find out, they are in series, right? We are going to find out how their potentials are divided. So let's say potential difference through R1 is V1 and through R2 is V2. දැන් මම මෙහෙම මේ කැලි දෙකක් ඇඳලා කියලා සර්කිට් එකට වෙනසක් වෙන්නේ නැහැ. right? කරන්ට් එකක් මෙහෙම එළියට පනින්න බෑනේ. so ඔයගේ දැන් තියෙනවා questions වල ඔයගොල්ලන්ව පටලවන්න හදලා. හරි? but a current can't flow no. So current can only flow in this direction. Right? It's a series connection. So same current flows through them. I. Right? So you can apply V equals IR for them. So applying Ohm's law, we are going to find the resistance, the voltages across them, right? We're going to find expressions for them. Applying Ohm's law. V1 will be equal to Ohm's law, V equals IR. Voltage across R1 will be equal to I, that current, into R1. And for R2, it will be V2 equals I, same current, into R2. So you can see it's the same current, no? For them. So if I is constant, we can write V1 proportional R1 and V2 proportional to R2. නේද? එතකොට මෙයාගේ resistance එක වැඩි වුණොත් yes overall resistance වැඩිලා current එක අඩු වෙනවා. But මේ දෙන්න එකට ගත්තාම they have the same current going through them at a given instant. So higher the resistance, higher the voltage. So to confirm that further, let's get an expression for current. So for the whole circuit, we can apply V equals IR. V is equal to I into the equivalent resistance, which is R1 plus R2. I is equal to V over R, V over R1 plus R2. So you can sub that in these two equations. One other to find V1 and V2. V1 is equal to I is V over R1 plus R2 into R1, this one. Then V2 equals I is V over R1 plus R2 into R2. Just rearrange them so you get the resistances together. R1 over R1 plus R2 into V. V2 is equal to R2 over R1 plus R2 into B. What does this give you? What does this show you? What the pin? You can see that when power source is given, when voltage source is given, right? The voltage for a given resistor, V1 or V2, will depend on their resistance ratio. Ne? R1 is the resistance of R1 divided by the total resistance, R1 or R1 plus R2. Here for V2, to get V2, R2 over R1 plus R2, right? Resistance ratio for R2. R2 divided by the total resistance. තුනක් තිබ්බොත් it's the value of the resistance divided by R1 plus R2 plus R3. Part of unknown මොකක්ද කියන එක මත depend වෙනවා. There will be V3 also තුනක්. Okay, so that is why it says here, you can underline if you want, potential divides to the ratio of resistance when the current is equal. So this is applicable for series ones. Yes, for parallel ones, potential is not divided, no? It's the same, no? So potential division, so potential divider method is usually applied for series. හැබැයි මේක මේ විදිහටම දෙන්නේ නෑ අකුරට. We will go to questions and see, right? So copy this down and we will go to question. Shall we go to question? Is there anyone who's still writing? Okay, then we go to question. Okay, do the first one. We'll do one or two, three sums and do the rest one. The first one. So you have to get V in terms of R1, R2, R3, and E. So it's pretty, this first one is pretty simple, no? So you can write it's divided based on the resistance ratios. තුනක් තියෙනවා series නේ. So they are asking for R3. It will be R3 over R1 plus R2 plus R3. This is the resistance ratio for R3. And based on this ratio, E will be divided to R3. This is V for R3. අර මං කිව්ව එකම තමයි. And it's hard for you to send in the chat නේ මෙහෙම කියලා. So let's do the second one. Find V in terms of R and E. දැන් මෙතන එනවා ලස්සන්ට උත්තර because everything's given in R terms of R නේ. So you get a fraction of E for an answer. So you can send the answer. What do you get as the answer? I didn't think this many would show up for the class today because it was raining the whole day. So on rainy days, us Sri Lankan people like to sleep full day. So I'm happy that you all are here. And right, so what I have to say is like අනිත් අය නිදා ගන්න වෙලාවටත් වැඩ කරන කට්ටිය තමයි උඩටම එන්නේ අන්තිමට. That is true for A levels, true for anything, true for sports, true for life, right? The ones who work when others are sleeping are the people who come on top in anything in life, right? In life in general as well. Correct. I mean, you all don't go to school that much during this is your second year again, A level. So if you take A level as 3 years, මැද කාලෙද? Like those days, we used to go to school bit more than you guys, not a lot. Sita තිබ්බේ නෑ. But a bit more than you are. At 65% විතර attendance තිබ්බා. So like what I did during those days was I used to get up at around 4, I think. ඉස්කෝලේ යන නොයන දවස් අදාළ නැහැ හැමදාම වගේ during this time, right? I got up at around 4 to study bio, not to study anything else. To study bio mainly because that was the subject that I didn't like. So, and the morning was a very quiet time, no? So no one was awake, and you can feel that you can feel that the whole world is asleep during that time. No vehicle sounds, nothing at all, not even the birds or insects or anything, no. So you know that you get a nice feeling sometimes. Some like you're sleepy, obviously at the first, but when you start to work, you'll be fine, no? So you get a nice feeling at around like after you got into the groove and started studying, when you hear no sounds and you know everyone's sleeping right now, and I'm the only one who's awake and working. Like it get it gives you a bit of personal motivation, you know. I mean, I'm not asking you to get up and study, but some people are night owls and some are early risers. Now I'm a night owl. I can't rise early to study. So now I can stay till about 3 a.m., 4 a.m., but I can't wake up. It's difficult for me to wake up. So uh, it depends on how we are used to. So if you're a night owl, then stay up late. Even if you stay up till 3 a.m., you will feel that no one's sleeping at 3 a.m. Everyone's sleeping at 3 a.m. Okay. That same feeling. So you can do it like without uh, not sleeping till late as well. දෙදි මරන්න එහෙම නැතුව කරන්න පුළුවන්. ඒක බැරි නෑ. හරි. But the thing is to work when others don't. Right? It's not overworking like a robot, but working consistently even when others are not. Only then you can be free after your O-levels. Otherwise, you'll always think, what if I had worked a bit more? What if I had done the homework? What if I had studied the theory a bit more? What if I had done this every week? I mean, I'm not asking you all to study all the time, every day, no? Right? During this time, around 5 to 6 hours of work is enough. If you don't go to school, if you go to school, around 3 to 4 hours, like on days which you don't have classes, obviously. If you have classes, around 2 to 3 hours will be possible now. So the key is being consistent. It's not about how much work you do on one day and the other day if you are sleeping. That's not good, right? So we will see the answer now. So now let's see. So this is so all other questions will be like this. No? So it's like this. Now there are two resistances in parallel, right? And they're asking the voltage that this parallel combination gets. So this one gets. So you can't solve it directly now because you need the resistance here for that voltage. So you have to get the parallel equivalent resistance for these two. So R and R will be R over 2. This will be R anyways. And what they're asking is this, no? Because even if you separate them as R and R or put R over 2 instead of those two resistances, you have to get the same voltage because that's what equivalent resistance means. Now you have two. So what do? Potential divider method. So the long way is that you first calculate the current, right? Dividing E by the total resistance of these two, and then putting V equals IR for this. You get the same answer, but it's a bit long. You can use the potential divider method to get it faster. So the resistance is now R over 2, right? And the total resistance is R plus R over 2. This is the ratio for R over 2. They can ask for R as well. Then also you will need to solve this. But on the numerator, you have to put R if they ask for this side. But they're asking for the lower one into V. So here numerator 2 into 2 common denominator, right? So R over 2 into 1 over this is 2R plus R over 2. This gets cut into V. That will be R over 2R plus R is 3R into E, sorry, not V. This should be E. This should be E. So R and R also get cut. You get E over 3. Did everyone understand that, or should I explain that again? Yes. So do the, I put this again. Do the, yeah, do the fourth one. The third one is what we did. Now do this one, fourth one. For those who couldn't copy this down, you can copy this. Do the fourth one. I can just scroll it down. Do the fourth one. So what I was going to tell was that consistency and hard work will beat skill any day. It's not how brainy you are or how smart you are or how intelligent or how wise you are that matters. What matters is how many times you do it over and over again, how many times you practice, how many times you do the same thing over and over again until it gets as close to perfect as possible, right? If you take 9 out of the top 10 island rankers, they will be hardworking students, not the most intelligent. One will be most intelligent because they are that kind of people as well, no? But most of them will be just normal students, just like you are, right? Like just like us. That's the average population, right? That's 80% of 80-90% of the population is normal people. But if normal people work consistently over and over again, they will at any given time they can go beyond those intelligent and the what we call the brainiacs, right? So hard work and consistent work is what matters. What do you get for the fourth one? You can do the rest for homework, right? Uh, yeah, all these four we will discuss next day. Mark them. All four will be for homework. If you have sent the answer, check for which resistor, they are asking the potential. Now, you can use the same method that I use. How I got the equivalent resistances, right? And like that. So, but here it's a bit like another step further because you can see, like, compare this, the fourth question to the second one. You can see what they are asking is not the same thing as in the second one, a bit different. So after the class today, I will send a Google form just to get a feedback on the 3 days. And also, like from next month onwards, there's 2 days still left for this class, this month now. So from next month onwards, if there is like good enough physical participation, uh, we can do physically. Otherwise, we will continue online. Uh, so just fill the Google the in the like the Google form I put like in addition to any feedback, just pick whether you will like to continue attending physically or online. And for the like since this is the last 3 day, for the next 2 days, the like for from next month onwards, the fee is 3,500 for per month. But for only for the next 2 days, the fee will be 1,000. So both days fee is 1,000, right? Not 1,000 separately. 1,000 for the month, rest of the June month, right? From July, it's 3,500. Uh, for this month only, it will be 1,000 rupees. I will put a Google form saying how you have to make the payment. So if there are any inquiries, you can ask me through WhatsApp or call me. Right? Shall we discuss? So you can see they are asking us about this 3R resistor, right? Earlier they asked this like the half of it. Now half was this now, but now they're asking someone which is inside that. So first we need to deconstruct it, like get the equivalent connection. No? So here 3 and 3. 3 and 3 becomes 6. 2R 6R and 3R. E. So you can see 3R and 6R in parallel. What's the value? We did a number of times, no? 3R and 6R will give you 2R. So you can see 2R and 2R. So E would be divided equally between them. So E over 2, E over 2 for 2R, right? That is, you have to draw these potential differences on your diagram. Then only you will see what it is for. Now E over 2 for this 2R and the other E over 2 is not for this. No, it's for the whole connection from here to here. For this 3R, yes, it will be E over 2 because like from this point to this point, it's E over 2. But for this 3R, it will be different for this guy here, what they're asking. Now, both these together get E over 2, right? Both of them together. So either you can apply potential divider method to these two separately, or you can do that is for them together it's E over 2. So V will be equal to 3R over 3R plus 3R into E over 2. So you get 3R over 6R into E over 2. That's E over 4. Half of E over 2. Or just, you can take it logically, 3R, E over 2 must be divided equally, So V equals E over 2 into half. E over 4. Okay? Any questions on that? Because we'll be going on to Wheatstone bridge now. Next. So practice them again, right? It's not about the number of questions you do, it's like the number of questions will matter, like the normal number is okay. But it's mostly about how many times you do the same question and understand the same thing again and again. Like when you see, you might even find new methods to do these questions, new shorter methods, right? Because there's no one way, no specific correct way to do it. There are many correct ways. Okay, let's go to the next part then, right? Is anyone still writing? Okay. Then we go on to Wheatstone bridge. So after that, these are like separate parts. We'll do them. We'll start energy and power next week. Then after that, it's just those parts we can like finish them quickly because we've done the basic stuff. Then the curve of stuff, so not that hard. Okay, potential divider. Wait there. Right. So Wheatstone bridge concept. This also is another thing that we have already done. So they're just giving names to stuff that we know, ne? So there's a circuit now. Then label the currents I1, I2, and this current, let's say current through this middle resistor, I. Then the current through R2 is I3. This is Sorry, this is I3 and this is I2. R2 for I2 is easy, right? So let's take this point as A and this point as B. So you can see now we are going to take I, right? We are going to take uh, this is RS, right? This one. We are going to assume that there is no current through the resistor RS in the given circuit. So we are going to assume if this current is zero, if that current is zero, that means there is no current through RS. If there is no current through a resistor, that means there is no potential difference across the points of that resistor. No? So let's take this point as C and this point as D. There will be no potential difference across C and D. So therefore, VC equals VD. VC is equal to VD. All right. That means VA minus VC. That is this VA minus VC. Potential at A minus potential at C. That is you can write it as VAC is equal to I1 into R1. And you can write for this as well, because VC and VD are equal. VA minus VD is equal to VAD, which is I3 into R3. So you can get it as 1 and 2. So since VC is equal to VD, 1 is equal to 2, right? Because A and A are same point, C and C also same potential. So starting point and ending points are the same. Starting point is definitely same. Ending point is similar potential. So the differences are same, right? You can write I1 R1 is equal to I3 R3. Third equation. Then again we can write, since this and this are the same potential, they meet at the common point as well. So their starting points are similar and they meet at the common point. So VC minus VB is equal to VCB, which is equal to I2 into R2. Instead of I2, I am going to write I2 equals I1. Why? Because if no current flows through this, then I1 should continue. I1 into R2, fourth equation. And VD minus VB, this one, is equal to VDB. That this current I4 will be equal to I3. Why? If no current comes downwards and gets added to I3, right, then I3 should continue through the bend. Yeah. You can write I3 into R4, fifth equation. You can equalize them. 4 equals 5. I1 R2 equals I3 R4. Sixth one now. So we are going to get the ratio of them. 3 over 6. I1 R1 over I1 R2 is equal to I3 R3 over I3 R4. Currents get cut. So you get R1 over R2 is equal to R3 over R4. That means this over this. මේ එකම line එකේ ඉන්න දෙන්නගේ ratio එක equal මේ දෙන්නගේ ratio එකට. Or you can just swap R2 and R3, ඔය හරහට ඉන්න අය මාරු කරන්න පුළුවන්. So you get R1 over R3 equals R2 over R4. Yes, මේක ඕ මේක දෙකම හරි. So you can write it as R1 over R3. Yes, මෙයා over මෙයා උඩ දෙන්න නේ. Parallel ඉන්න දෙන්න R1 over R3 equals R2 over R4. Okay, that is the Wheatstone bridge concept. And like then ඒක ගත්තේ අපි if there is no current through the resistor කියලානේ. So we are going to get it in the other way. If the resistors give this ratio, if R1 over R2 is equal to R3 over R4, or if R1, the other way, they come again. If this resistance ratio is like this, R1 over R2 equals R3 over R4 num, then the current through the middle resistor will be zero. Ne? If it works in one direction, it should be the same in the other way. Ne? I current එක 0 වුණාම මේ ratio එක එනවා නම් මේ ratio එක ආවහම මැද current එක 0 වෙනවා. Get it? Okay, that's Wheatstone concept. Wheatstone concept කියන්නේ මේකට. හැබැයි අපි එකට එන්නේ current එක 0 නම් කියලා assume කරලා. So you can just remove neither. You can either remove it or you can connect the 2 points. So we are going to solve this system. Maybe bridge එකක් නෙමෙයි. This is called the Wheatstone bridge. We are going to solve it. So it can be solved by two methods. One is then, since there is no potential difference between C and D, there is no point in keeping the resistor. So you can just remove it. So what you get is something like this. The diamond එකක් වගේ ගන්න. So R1, R2, R3, R4. Then you can solve it like you normally solve. නේද? R1 and R2 series, R3, R4 series. Right? ඒක series solve කරලා පෙන්නන්න ඕනේ නෑනේ. Or what you can do is, if current is zero, that means it's like a conducting wire. නේද? Resistance එක zero now, right? It's like resistance zero. There is a conducting wire there. That means these points can be connected. So here, යටයි මෙහෙම අර pinch කරනවා කියලා මම අපි කිව්වේ. ඒවත් නේද? R1 and R3 are parallel and R2 and R4 are parallel. Right? ඔය විදි දෙකෙන්ම එන්නේ ඔක්කොම උත්තරේ. So you can either think in this case, with second case, we thought of it as a conducting wire instead of a resistance. That means its resistance is zero, conducting wire so resistance then. Or in this case, we thought it doesn't exist. That means current යන්නේ කියන්නේ resistance infinity. Yeah, it's like resistance is infinity. That's why current is not going. You can think of it like this and solve it in two ways. දෙකෙන් එකක් පාවිච්චි කරන්න. Right? Okay. Write this proof. Yeah, if physical classes are there, it will most probably on Saturday and not the same time, obviously. It will be around like in the evening, right? 2:30 to in the evening, after 12 anyways, right? It will be on Saturday. So I will send those all the details like through the phone. So read it carefully and I will put a message on the group as well. But for this month, it will be online. So from next month onwards, if there is enough physical participation, if people like to do the class physically, I will try to do it. Yeah? Okay. Shall we go to some questions? We'll do one question and I'll give you the rest for homework. Okay, no? So try to get the Wheatstone bridge concept, like study the concept and try to do it by yourself. Because then you understand a lot. when you try to do the theory by yourself. Okay. Wheatstone bridge. Where can we find it? So this question is the same thing, right? That I gave. So do 39. Instead of that other cube question, do 39. This is more informative. It will be easier for you. Yeah, do this one. 44. So 44, the diagram for 44 is this. Okay. We'll do two questions, 44 and 45, because it is like otherwise there's no point in completing the theory. So let's do 44. That's easy. Send your answers. Can send the answer. So now we did Wheatstone bridge now. So you have to see whether this is a Wheatstone bridge. Right. Shall we see? So to see whether it's a Wheatstone bridge, take the resistance ratios. Hmm? R1 over R2, R1 over R3 equals R2 over R4. So R1 is 10. This is 25. Right? 10 over 25. And this is 2 over 5. So is it the same? Here 10 means 5, 2 times 5, 2 times, sorry, 5 times 5 is 25. So 2 over 5 equals 2 over 5, no? So you get the resistance ratio is same. So it's a Wheatstone bridge. No? It's a Wheatstone bridge. So the current in this is 0. So you don't need that. You can redraw it. You can redraw it without the wire. Now 1.4 amperes is coming. So here 10, here 2, here 25 and 5. So in the upper section you have 12, lower it's 30, right? So let's take the current, casting current through the 2 ohm. No? So it's the current, same current through the 10. No? Let's take it as I. So then whatever the current remaining should flow through 25 and 5, 1.4 minus I, right? Through these two. So 12 is in parallel now. These two becomes 12 now. This becomes 30 ohms. So here is I, here 1.4 minus I. So this combination is now parallel. It is a parallel combination, right? So what can we equalize? Voltage equals IR. For both of them, voltage is the same. So 12 into I should be equal to 30 into 1.4 minus I, right? Divide by, cut by 6, 2, 5. 2I equals 5 into 1.4 is 7 minus 5I. 5I goes to the other side becomes plus 5I plus 2I, 7I equals 7. I equals 1, 7 divided by 7. So current through 2 is also 1 ampere. 10 is also 1 ampere. Same current, no? Okay. Did you understand or are there any questions? Okay. Right. Do 45th one also. 45th one. The key here is either you can draw the circuit another way or look at the circuit clearly. Then you'll see what it is. Mark the 43rd one for homework. And 36 as well. 36 is easy. I'll send the answers to the group for 36. If I don't send in before like Friday or Thursday, just send me a message. Just remind me, okay. 36 one, I'll send the answers to the group because like, we don't need to discuss it because it's kind of simple thing. 43rd one also homework. 47th one also homework. 43, 47. I'll tell the rest of the homework after we discuss this. So how do we do this? Just now we learned the concept. You have to see how the resistors are arranged. No? Asking the current through the battery. You know the voltage. V equals IR. You know V. They're asking us I. So you need the resistors. How do you get the resistors? What's the answer you got? Shall we check it? Now you can see you can't identify like there's 2 ohms here, 1 ohm going here, then 4 ohms going here, three going this way, two going that way. You can't really identify whether it's parallel or series by just looking at it. No? So you have to see whether it's a Wheatstone bridge there, because if you can't identify parallel or series connections, either it should be a symmetric resistance systems, which you can see it is not clearly in this scenario, or a Wheatstone bridge. So those are the possible things you have to see. First, see whether there are parallel or series resistances. Then, if there are not, see whether it's a symmetric resistance system, 3D or 2D. Then see whether it's a Wheatstone bridge, right? So that, like, as you practice, that would happen automatically, and you will judge it whether what you have to apply based on whether it's symmetric or not, whether there are parallel or series connections like that. So those are the four stuff that we know to solve resistances. So if it's not parallel and series or symmetric resistance systems, we have to check whether it's a Wheatstone bridge. So you can see here from this point, you get 1 ohm and there is 2 ohms. And between the end of 2 ohms and the end of 1 ohm, you get 3 ohms. No? You get from 2 ohms, there is 3 ohms. That is going to the end of 1 ohm. And from 2 ohm, another 4 ohm is also coming. And from 1 ohm, 2 ohms is also coming. So you have to check whether 1 over 2 is equal to 2 over 4. It's equal, no? It's half, no? It's half, no? So you don't need the third one. Wrong. You don't need the third one. Right? So just erase it. 3 is not necessary to get the equivalent resistance. No, they're asking current, no? To get equivalent resistance. 3 is not needed. So upper side, it's 3, no? 1 plus 2 is 3. Lower side, it's 2 plus 4, 6. 3 and 6, we made these two all day. 3 and 6 is 2 ohms. 2 ohms. And 2 volts. 2 ohms connected with 2 volts. 2 ohms is the equivalent resistance for 2 volts for this battery, for the connection now. So V equals IR. So just by looking at it now, you should be able to say that the current is 1 ampere. I is equal to V over R. 2 volt equal to I into 2 ohm. I is equal to 1 ampere. Current through the battery. Now, if they had asked the current through 1 ohm or current through 2 ohm, they can ask like that also. So you have to be always aware of what they are asking as the final answer, right? That can differ for the events for the same circuit. Okay, no? So we can stop there. The homework is the other questions I want to give. These you can just 45, 44, just 45 and 45. Right, so that's all for today. I will send the details regarding the plan for the next 2 weeks, uh, and like the fees and how we can pay as well. So if there are any inquiries, you can ask me. Uh, right, I'll send the form and everything tomorrow. Right? Okay, so I hope you all got the best out of these 3 sessions as well. Uh, okay, have a nice day. Good night. You're welcome.
Yeah.